Good morning, my dear students. Now we are going to start with the graphical method of analysis of earth pressure on retaining walls. The methods are called as Coulomb's law, Coulomb's wedge theory. In the second one we have a Raymond's graphical analysis, and the third one is Coulom's graphical analysis. These three we need to study. Now here just go back and we'll revise the Rankine's theory. Rankines is a one side, and this Coulomb and Raban and Coulomb is one side. Okay, just I am going to compare with you what all changes these three persons brought in this chapter, and what all the changes which are what are demerits which are seen in the Rankine's method, that we are going to see. See, the Rankine method, it is said that the if it is a retaining wall and this is a backfill, and Rankine said that the backfill must be cohesionless, isotropic, homogeneous, semi-infinite. Okay, semi-infinite means he assumed that the backfill is semi-infinite, homogeneous, isotropic, and cohesionless. Okay, now then these three persons also agree with this one. There is no change in this assumption. Means Coulomb also assumed these two. I will take it later. First I will consider Coulomb, because the Coulomb is the first person who introduced this wedge theory, that is a graphical method. This person is introduced, therefore I will consider Coulomb's theory and compare with the Rankine's theory. And this Coulomb's first assumption is same. The backfill is semi-infinite, homogeneous, isotropic, and cohesionless, that is C equal to 0. All are same. And coming to Rankine's method, the Rankine said that the top surface must be plane. Okay, either it is horizontal or it can be inclined. Okay, now then the second thing which is assumed by Coulomb is also same, that is the backfill, it must be a planar, either it is horizontal or it is inclined. Okay, now then coming to the Rankine assumed that the wall of the back of the retaining wall, the back of the retaining wall is vertical, but Coulomb said that need not be vertical. Means according to Coulomb, if the back of the retaining wall is inclined also, if the back of the retaining wall is inclined and your soil is resting here, then also his theory will be worked on this one. Therefore this is I can consider the demerit of Rankine's theory, that is he considered only vertical wall, but he considered vertical, inclined, everything. And the next one is Rankine considered that here the back of the retaining wall is smooth means it is a frictionless means there is a backfill here, and this is the wall, back of the wall, and there is no friction between the soil and the wall, he said. Okay, he ignored the frictional resistance by the wall to the soil. Okay, but Coulomb considered that one. Coulomb considered the friction between wall and soil. Okay, now Coulomb considered that one. And very important assumptions that is made by a Coulomb is that concept included by Coulomb is, look at here, the Rankine said that if this is a failure wedge, and we will call it as a slip surface or slip surface, then according to Rankine, he considered a small element inside the failure wedge and he dealt with the concept. We assumed there is a small wedge like this, and we got a vertical stress, horizontal stress, like that. Okay, here we considered a small element and after that we applied the concept. But this Coulomb will not consider the small. If this is a backfill, this is a retaining wall, okay, and this is a backfill, and this is a Rankine's retaining wall. Rankine considered a small element and applied sigma v, sigma h, and after that he dealt with the things. So means he considered a small element within the backfill of the soil. But here, this person, Coulomb, will not consider a small element, he will consider one entire wedge. This is called as A, B, and C. This is the entire wedge he is considering, and he is dealing with this entire wedge. Means when the retaining wall is moved away from the backfill, then this entire wedge will collapse, not an individual particle, not an individual part of the soil will collapse. He said that he assumed that when it moves, then the entire wedge will be moving. If it is moving away from, that is your active case, then it will be downwards. It will moving downwards. If it is a passive case moving towards the backfill, then it will move upward. But the action will be on the entire wedge. The action will be on the entire wedge. Okay, this is Coulomb's theory, and Coulomb further said that this wedge, whatever it is there here considered, that wedge is assumed as a rigid means again the same meaning, this will not collapse as a part by part. This wedge is there, no, ABC will not collapse by a part by part, it will be slided over this surface, or it will be moved upwards over this surface, but it will not fail by particle wise. No, this is the assumptions which is made by the Coulomb. Okay, considering these all concepts, Coulomb will give you one theory. Coulomb will give one theory that is called as Coulomb's wedge theory. Coulomb's wedge theory, and in this one he will give just one conclusion how to calculate earth pressure. This theory is just a conclusion. This is not we cannot able to apply this one practically. Therefore the person Rehban, the person Rehban worked on this Coulomb's theory and this conclusion. He considered this theory, these assumptions, this conclusion he considered, and he did so many experiments, and after that he came to one conclusion. That conclusion is called as Rehban's graphical theory. Graphical theory means I can say that the Rehban's graphical theory is that what one step ahead of this Coulomb's theory, one step ahead of Coulomb's theory. Then in Rehban's theory also he made the entire concept into three cases. He said that this case will be applicable for only that particular condition, this will be applicable for that particular, like that. Then again he got some demerits. Then the person will come, his name is Coulomb. The Coulomb graphical theory. Then comes Coulomb graphical theory. Coulomb graphical theory, I can say that it is one step ahead than the Rehban's theory. One step ahead than the Rehban's theory. Means all these theories are equal only. They have, means here the boss is the Coulomb, and he assumed so many things. He derived that equation, he derived that conclusion, and he got something concept, and after that Coulomb went. Then after that Rehban came and he implemented that one practically, how exactly we can calculate, how exactly we can draw and get the active earth pressure. He got it, and later Coulomb will again generalize the Rehban's method, and this will be over. Now we will go to Coulomb's theory. What exactly Coulomb concluded, that we will see. Coulomb's theory. Okay, now look at here. This is very important. For exam purpose only, you can in this one they can ask you what is Coulomb's theory, explain. Over. Only one question you can expect. You cannot expect even problems from this Coulomb's theory. Understanding is very important. Okay. Now look at it. This is your retaining wall. Okay. Look at here, inclined it is. This is inclined. That angle I will consider theta, and this is inclined with the horizontal. That angle I will consider beta. Okay, and this is my ground level, horizontal level. Any doubts? No doubts. This much is okay. Right? I will call this one as a and this point as a B. Now what Coulomb tells that if there is no retaining wall, what happens? Look at here. If consider this is a soil, This is a soil. Okay, and if there is no retaining wall and retaining wall is not at all moving, then you will get that soil will be naturally deposited this way, right? Naturally it will be deposited this way. Then this natural line is there, no, this is what called as natural slope. This natural slope for sand will be with respect to phi. Means whatever the angle of internal friction you are getting in the laboratory, that angle how much it is there, if it is a 30-degree, then that soil will be making its natural slope, that is phi angle with respect to horizontal. That concept we are using, and for this I will consider it as a D point. This I will consider D, A, B and D. Okay, and this, what is the name of this one? The name of this one is natural slope. Natural slope. Okay, or otherwise I can call this as a phi angle, no, therefore I can call this as a phi line. That is your phi line. Understood? Now according to this person, natural line is this one. Means when the retaining wall is there, then this cannot become a failure plane. This is not a failure plane. Then failure plane will be within the natural slope. Okay, that I will consider here. Okay, this I will consider here, and this I will call it as a C. Then ABC is a failure wedge. ABC is what? Triangle. ABC is a failure wedge. If it is exactly failing on BC plane, then I can call this surface as, that BC surface as critical slip surface. Critical slip surface. If it is exactly failing on BC, but I don't know, this is a randomly drawn. This BC is randomly drawn. Therefore, BC cannot be a critical. Now it cannot be a critical. Therefore, I will call it as just, it is a slip line. Slip line. Okay, then slip line at what angle? Some, I told you, no, some random angle. Therefore this is called as a lambda. Some random angle lambda, but lambda should be more than 5. Lambda should be more than 5. That conclusion also I will write here. The lambda, a random angle, and that should be more than 5. Okay, now here theta is there. Theta is called as a batter angle. Theta is what? Theta is a batter angle. Theta is a batter angle. Here many angles will come, right? And here there is a friction here between the wall and the wedge, because the wall is considered, a backside of the wall is considered rough. There is a friction, and that friction angle I will consider delta. Delta is what? A wall friction angle. It is wall friction angle. Okay, we got so many angles now. See, delta, lambda is a roughly we considered as a slip angle. Phi is the natural slope angle, or phi is the angle of internal friction, and theta is a batter angle, that is the back of the retaining wall, and delta is a friction angle, and beta is a ground angle, ground surface. No? These many angles are there. Don't get confused with this. Right? Now I drawn C here. Okay, then where are the what all forces will be acting on this wedge? Now our task is to consider this wedge only, that is A and C. This is B, A, B, C, A, B, C. This wedge only we need to consider. This wedge we need to consider, the yellow wedge we can call. Okay, on this yellow wedge there will be one force, that is it's the self weight of the yellow wedge, that is your W. W is what? Self weight. Now I can list here the weights. Weights are forces acting on trial wedge. Why it is called as trial wedge? We'll call weight force only. Why it is called trial wedge? Because I don't know whether BC is making a really a failure plane or not. Because this lambda is considered as a trial basis, therefore this ABC is a trial wedge. Then the first force acting on the trial wedge is its own weight. That is your delta W. Okay, that is your W, its own weight. And the second weight will be acting, that is the resistance by the wall, that exactly we will call, that will be equal to the active earth pressure. Active earth pressure usually we will show towards the wall, but wall is resisting, will consider like that, then wall is applying some active earth pressure. Therefore this is what a normal, this is a normal, and normal means what, perpendicular to the wall, and to that perpendicular I have a active earth pressure that will be drawn like this. This is my active earth pressure. Okay, then what is this angle? This is a delta. Normal to the surface, if there is no friction, then it will be perpendicular to the surface. Then there will be one resistance offered by the soil. This is a soil, no? Here the entire soil is there. This soil will hold this wedge upward. Therefore, there will be one force, another force here. That force is called as a R force. That force is R force. Just like in a wall, soil and wall, there was a angle, delta was a friction angle. Like that here, soil to soil, the angle is your phi angle. This is your phi angle, and this is your reaction R. That is your reaction R. Means how many forces are acting? The first one is a weight, and which is always vertical, and we have a PA, active earth pressure, acting from the wall, and the third one we have reaction from the soil to the wedge. Okay, these many forces are acting, these many forces are acting. Understood? Considering that this is equilibrium, the ABC is equilibrium under three forces, under these three forces, then I can show that graphically how we will show the equilibrium condition. If we draw three forces, then it will make a closed polygon. Closed polygon. See, this is my W, this is my W, and reaction is in this direction. This is my reaction, because see, the reaction is R in this direction, and PA is in this direction. PA is in this direction. Now means all three becomes what, making a closed polygon. Now I can consider that this is a PA, then consider that W, R and PA all are equilibrium. Okay, now okay, here in this one I want this angle, I want this angle. How to get this angle? Then look at here, what is that PA with respect to vertical I want. If I draw one vertical line here, if I draw one vertical line here, then what is this angle I am interested? What is this angle? Right? What is that angle? Any idea? Think. That is, this is a delta and this is a theta. Therefore, this is 90 minus theta. Simply, we will call it as a psi angle, a new angle I am introducing. That is your psi angle. Psi equal to 90 minus theta minus delta. Then I will write this one as a psi angle. Okay, na? Then what about this angle I want? What about this angle? This angle is a R with respect to vertical. If I draw one line here, then what is this angle? What is this angle? This angle is lambda minus phi angle. Lambda minus phi angle. You can just work out that, you will get lambda minus phi angle. Understood? Now this one I don't know, let it be. Then this one lambda minus phi and psi angle, we got it. Any doubts here? Now our task is get the best angle possible, that is a lambda, so that we can get the exact failure wedge. When we get the exact failure wedge, then I can say that corresponding PA is a active earth pressure. Okay, for that one Coulomb tells this one, he tells us to draw one perpendicular line to this phi line. Okay, we'll draw one perpendicular line to this one, right? And one perpendicular line to same again from this D line. This is a perpendicular line to D line. Then we will name this as a N, and we will name this as a X, and your total BD is called as a M. CF is a X. CF is a X. Then after that, he again tell us to draw one more line. That line is like this, and this line is an angle is your E point. We need to draw like. Now compare BCE force triangle. Force triangle. Okay. Now look at here. There is a psi here. There is a psi here. Okay. Na? This psi and this psi same. Then if it is a total is a lambda and this is a phi, then what about this angle? This is again lambda minus phi. Then again here lambda minus phi. Means this is a psi, here is a psi. Here is a lambda minus phi, here is a lambda minus phi. Means these two triangles are similar. Similar. Then which is the longest side? Which one side? The longest side here is a W and the longest side here is a BE. Okay, and with respect to BE, CE is there. Therefore, with respect to W, PA is there. Understood? Means these two are somewhat similar triangle. Considering the similar triangular approach, then I can say that W by means here W means what? The longest, and the longest is BE. The W by BE is equal to, and here CE and here PA both are same. Therefore, PA divided by CE. Then you can have a equation PA is equal to W into CE divided by BE. Okay, you got the pressure PA equal to what? Now if we calculate W and if we calculate CE and BE, then active earth pressure is over. Now we'll go ahead. Then what is this W? W is equal to the weight of a triangle ABC. Then how to get this one? Gamma into area of ABC into 1 meter. Then it become a volume, right? Now gamma into, how to get the area of ABC? Area of ABC we can get it by the area of ABD minus the area of BCD. Okay, na? Right? Then what is the area of ABD? ABD is the area. Perpendicular line is N. Therefore, half into base into height. Therefore, half into base is a M and height is a gamma into half into base into height minus, and this BCD here you can see this is half into base is M and height is X. Therefore, this is half into base into X. Now I got this one. This is your W. One parameter is got. Then the second parameter will go, what is CE? Okay, what is CE? Then what is CE? Just look at here. Where is CE? And CE is here. CE is here, and by using this triangle, that is a CFE triangle. What is that? C and X it is, and FE, and this is a perpendicular. This is a psi angle. Here I can use, I want what? I want CE, I want, this is X is known. Therefore, which one? Sin theta I will use. Okay. Sin psi is equal to opposite divided by hypotenuse. Hypotenuse is CE. Then CE equal to X cosecant phi. X cosecant phi. Phi is always a constant. What is a psi? Psi is equal to what? Psi is a 90 minus theta minus delta. Here theta is a constant, that depending on the better angle. Delta is the wall friction constant. Therefore, I can consider CE is equal to X into A1. A1 is what? A1 is just I introduced here, that is a constant. Then I will write CE equal to X into A1. CE equal to X into A1 over. Now I will come to BE. This I want. Okay. then I want BE. Then what is the BE? Look at here. Where is that BE? B and E. This is the BE. BE equal to BD minus ED, right? BE equal to BD minus ED, right? BD minus ED. Then here I can make it like this ED. We'll look at ED. This ED I can call it as a DF minus EF. DF minus EF it is. DF minus EF is your BD, right? Now I need to work out this one. What is BD? B into D, that is your M. Okay, na? That is your M minus DF I want. DF I want. DF is what? We'll consider the big triangle. This is your X, this is your D, and this is your F. We want DF. DF means this one. Then this angle is 90 degree, and this angle is what? This angle is phi minus beta. That is a phi minus beta angle. How it is got phi minus beta angle? That you need to work out. Here phi is there, here beta is there. That you need to work out. That is, this is the wall, and this is your phi angle, and this is a beta angle. If I extend this beta angle, then what happens? This is your phi angle. Then this is what? This is 180 minus phi angle. 180 minus phi. This is 180 minus phi. This is a beta. Then you call it as a some D angle. Angle D. Then the sum of all must be what? Oh, 180. Right? Then sum of beta plus 180 minus phi, beta plus 180 minus phi plus angle delta, angle D is equal to 180. It should be. Then 180 cancel. Then the angle D is equal to this phi will come that side plus phi minus beta. Therefore you got this is phi minus beta. This is your phi minus beta. Now come to this triangle. This is your phi minus beta angle. Then define this one. We want this opposite is there, adjacent is there. Therefore tan theta will define. Tan phi minus beta is equal to tan phi minus opposite divided by DE. Then if I want DE, then DE equal to, then I will write here x cot phi minus beta minus what is EF. Now we have one more line here. This is your E and this is your EF. Now we are interested in EF. Then this angle is psi angle. It's already there in the diagram, you can see. Then this will be x cot psi. Okay. Then M and x minus x is taken common. Cot phi minus beta minus cot psi. Now phi is a constant, beta is a constant, psi is a constant. Therefore I can write it as a M minus x into A2. A2 is what? One more constant. Therefore BE I got it. Okay, now I got all three variables W, CE and BE I got. Now I will write that. Okay. Look at here. PA equal to W into CE divided by BE. Then W is what? Half into and take gamma outside, M outside. Gamma is already outside. Half and M you take outside. Then gamma M into N minus X. This is your W, and into CE. CE is XA1, that is XA1 divided by BE. BE is M minus XA2. M minus XA2. Okay, na? Then I will write it like half into gamma into M. That A1 I will bring it this side, A1, and the bracket is left here is N minus X divided by M minus XA2. This I got. Right? I think one more X. This X is there, no? That X I will multiply X and X square. Okay? This is my PA. Okay, but this PA is depending on the x. Okay, then x is depending on what? Look at here, this x is depending on the lambda value, this lambda value, therefore that x as a variable. To get the maximum possible value of x, then what I have to do? Differentiate PA with respect to x and equate to 0, then you will get the condition. Then this half gamma m a1 constant and differentiation of this one denominator square m minus x a2 whole square, the denominator as it is m minus x a2 as it is, into numerator differentiation n minus 2x minus numerator as it is nx minus x square as it is, differentiation of denominator is m minus m gone, then minus a2 equal to 0. Then I will get this term becomes 0, the denominator becomes 0, the numerator will be m minus x a2 into n minus 2x minus equal to 0. Then this minus becomes plus. Okay, now I will send this entire term that side. No problem, no problem, keep it here only, and we'll resolve the brackets, right? Look at here, a2 nx, these are cancel. Then here 2x square a2 and x square a2, therefore 1x square a2. Now what I will do? I will do some magic here, mn minus mx minus mx, right? Now I will keep this one this side and I will send that side. M minus x a2 is what? BE. This is mn minus mx. Okay. Now I will divide entire equation by 2. Then what is this? Half mn minus half mx. That is area of BCE. Okay, that is area of BCE. Now what is this? ABD minus BCD? ABC. Half into area of conclusion. If you achieve this area and this area equal, then in that way if you get a PA, that PA is a maximum PA conclusion. Okay, means what? Come back. Here they are going to tell you that this triangle area and this triangle, this triangle area, okay, these two must be equal in such a way that you need to draw a BC line. In such a way you need to draw BC line with the lambda, then you will get a PA maximum. This much was said by the Coulomb, and after that this will be carried forward by Ray. Okay, that we will see in the next class.